Okay, going to be working here 11.4, tangent planes. Going to be working problems 1 through 6. All right, so number 1. Find the equation of the plane to the given surface at the specified point. So 1, here we go, we've got z equals 3y squared minus 2x squared plus x, and at the point 2, -1, -3. All right, so first things first, we're going to make sure we understand the formula. The formula is going to be the partial of f with respect to x at a, b times x minus x naught plus partial f with respect to y at a, b, y minus y naught. And, well, you know what? We should replace a, b with x naught, y naught. X naught, y naught, x naught, y naught. And then this one will always be minus 1, z minus z naught equals 0. So this point right here gives us our x naught, y naught, z naught. And so we're just going to need to figure out these pieces here. This right here, right, that's the a, the b, and the c of the normal vector. So the normal vector for this plane has as its components a, b, c, and then the rest of it we just get from this point. So let me first find the partial of f with respect to x. So the partial of f with respect to x, I'll go ahead and treat y like a constant. Take derivative here, it's going to be 0, -4x, and then plus 1. While I'm here, I may as well get the partial with respect to y, which in this case, those are constants, so that's 0, you just get 6y. Now, let me go ahead and plug in partial with respect to x at x naught, y naught. X naught's 2, y naught's -1. So if I replace the x here with 2 and the y with -1, well, there is no y here, so I'm just going to plug in a 2 here. -4 times 2 plus 1 is -7. And then for the other one, I'm going to do the partial of f with respect to y at the same point. Again, x is not there this time, and so I just plug in -1 for y, we get -6. And so now I can rewrite this formula here. I'll just squeeze it in right here. This right here is going to be -7, so -7, x minus x naught is 2, plus this number right here, which is -6, so -6. Y minus y naught is y minus -1, so plus 1. And then over here, minus 1 times z minus -3 is plus 3 equals 0. So that is the equation of the plane, but I'm going to distribute through and clean it up and make it look like that other version. So -7x plus 14 minus 6y minus 6 minus z minus 3 equals 0. Get all my x's together, -7x minus 6y minus z equals, let's see, 14 take away 6 is 8, take away 3 is 5, so I have a 5 on that side, I'll bring it to the other side, -5. That should be the equation of the plane that's tangent to this surface at that given point. Okay, so number 2, I have, I guess I'll do 2. So for number 2, z is equal to 3 times the quantity x minus 1 squared 2 times quantity y plus 3 squared and plus 7. And the point is 2, negative 2, 12. All right, so I'll go a little quicker through this one. Partial of f with respect to x, well, this is all going to be constant, so 0. Just do derivative of this. So 2 drops out, 6, x minus 1 to the first power, times the derivative of what's inside, which is just 1. Partial of f with respect to y is going to be, this is a constant, so they're gone just here. So 2 drops out, I get 4, y plus 3 to the first power, and then derivative of what's inside, which is just 1. Now I'm going to plug in to this partial x naught, y naught, which only the 2 matters here, so 2 minus 1 is 1, so you just get 6 here. If I do the partial of f with respect to y at 2, negative 2, the 2 won't matter, I just plug negative 2 in here. Negative 2 plus 3 is 1 times 4, so I get 4. So I'm ready for my formula. I'm going to do this number, 6, times x minus x naught, plus this number right here, 4 times y minus negative 2 is plus 2, and then plus, or sorry, it's always minus 1. And then z minus 12 equals 0. And now I'm going to go ahead and just clean this up. 6x minus 12 plus 4y plus 8 minus z plus 12 equals 0. 6x plus 4y minus z equals, let me get my constants here, negative 4, oh wait, these are gone. Negative 12 and 12 gone, so I just have 8. I'll just take that to the other side, minus 8. Okay. So that's number 2. All right, let's look at number 3. Wait a minute. Number 3 looks familiar. That looks like the mini exam problem. Make sure it's not the mini exam problem. That's really weird. I'm missing the mini exam in here. Not sure where it is. Oh well. Interesting. Well, I'm going to do it anyway. So z is square root of xy at the point 1, 1, 1. All right, so here we go. Partial of f with respect to x. All right, derivative of the square root of something is 1 over 2 times the root of what's there, times the derivative of what's inside. Derivative of what's inside with respect to x. That means treat y like a constant, so it's going to come with me. Derivative of x is 1, so you just get y. So y over 2 root xy. Now the partial derivative of f with respect to y, same story, 1 over 2 root xy, but this time times x. So x over 2 root xy. Now the partial of f with respect to x at 1, 1. So I plug in 1 for x and y. I get 1 over, see 1 times 1 is 1, square root of 1 is 1, 2, so we just get 1/2. And we're going to get the exact same thing here. So now I just write my formula. So it's 1/2 x minus x naught plus 1/2 y minus y naught minus 1 z minus z naught equals 0. Let me multiply everything by 2. So that'll make that a 1, that'll make that a 1, that'll make that a negative 2. On the other side, the 0 is gone. So I just have x minus 1 plus y minus 1 minus distribute a negative 2 through, negative 2z plus 2 equals 0. And that becomes x plus y plus, or x plus y minus 2z equals, let's see number-wise, negative 1. So negative 2, this is a 2. So negative 2 plus 2 is 0, so 0. All right, let's look at number 4. Okay, 4. Ooh, z equals x e to the xy. At the point 2, where am I? 2, 0, 2. So partial of f with respect to x. That means I have to do a product rule. So I've got e to the xy plus derivative of e to the xy is itself times derivative of what's inside, or what's up here, which is going to be just y, but then finish off the product rule times x. So that's just e to the xy. How do I want to do that? Since they both have those, I'm going to factor one out. Be left with 1 plus xy. Now I'm going to do partial with respect to y. So this time I don't need a product rule, because that's a constant. So it's x, now the derivative of e to the xy is itself, times derivative of what's up here with respect to y, which gives you just x. So x squared e to the xy. Now let's plug in our conditions here. Plug in 2, 0, so I'm plugging in here and here. Let's see, e to the, let's see, 2 times 0 is 0. Then 1 plus 2 times 0 is just 1. E to the 0 is 1, so that's just 1. Now plug in, again, 2 for x, so we get 4, right? E to the 2 times 0 is 0, so e to the 0, you get 1, so just 4. And then we come up with our equation. So it's the first number 1, x minus x naught plus 4 times y minus y naught minus 1 times z minus z naught equals 0. And I think I'll just leave you for the rest on that one to multiply that out. Okay. See number 5. Number 5. X sine of x plus y. And the point we have is negative 1, 1, 0. Keep in mind this point actually lives on that function, like if you, or on that curve, that surface, sorry. If you plug this point in, it should satisfy that equation. But partial of f with respect to x, product rule. Okay, so derivative of that one's 1 times the second one, plus derivative of the second one, which is cosine x plus y, times derivative of what's inside. Derivative of x with respect to x is 1, plus derivative of y, which is 0, so just 1 out here, but then times x to finish off the product rule. And then I'll do derivative with respect to y now. So no product rule necessary. X is going to come along. Derivative of sine of something is cosine, x plus y, times derivative of what's inside with respect to y. So derivative of x is 0, derivative of y is 1. So there's a 1 here. Good. Now plug in the point negative 1, 1. So let's see what happens here. Right here, When I plug in -1 and 1 here, I get 0, sine of 0, 0, good. -1 and 1 here, get 0, cosine of 0 is 1, but then times x, which is -1, so I get -1 here. Okay, plug in -1 for x, you get -1 times, let's see, -1 plus 1 is 0, cosine of 0 is 1, so you get 1. So you get -1 there. So now I'm ready for the formula. -1, x minus x naught, so it becomes plus. Minus 1 times y minus y naught minus 1 times z minus 0, z naught, equals 0. So -x minus 1 or minus y plus 1 minus z equals 0. And if you move all the variables to the right side and then your numbers cancel, you get 0 equals x plus y plus z. So that's number 5. Number 6. I think I'll let you do 6. I don't see anything real tricky in 6. All right, that's it. That's just basic, you know, I didn't ask you too many problems in this section because I want to keep it simple. Just make sure you know how to use that formula to get the equation of the tangent plane to a surface.